Hey, everybody. Hope everybody's having a good day. Let's take a look at everybody's school picture. Look at you guys.
Mine isn't that bad.
Shout out Cole. Hey, Cole. Hope everybody. Oh, Jacob too. Hope everybody's doing well at home. Okay. Right here.
That's pretty. Can I call you John? Can I call you Donald?
What was his real name?
Donald. That's so funny.
Don.
Hey, Donald.
All right, here we go. So there's 20 and 22. Remember, we got a quiz on Friday.
Oh.
It's just not the morning.
We get a quiz on Friday, and then next Friday, we're going to do a group test.
No.
It's going to be a good time.
Yeah, that's a good question.
We had like 7.
I love group test days.
Good for you. I mean, really good time.
Yeah, I think they're fun.
So what do I do then?
Well, I'll put you. I assign groups in the group test day, so you don't pick them. Sorry.
That's kind of kind of ruined the whole fun. We
Yep.
like all do it together.
Here is 22. Usually it's groups of 3. So that I can assign.
Cole's not here.
The Cole.
Who knows?
Oh well. Who knows? Who knows? Who knows?
It's Cole. 3.
All right, there's the work again for 22. Again, what you see in blue is how you get it down to the factors at x squared plus 4, x squared minus 2x plus 2. You know, if you have friends in Mrs. Napoles' class, I know she teaches it. No, she used to teach it a different way. I don't know if she still does teach it this way. But if you've got 1 plus or minus I, you can treat that. Let me plug in here. You can treat that as 2 separate roots and say x is equal to 1 minus I, x is equal to 1 plus I. And then you can actually get everything over to the other side without doing any square roots. X minus 1 minus I is equal to 0. And then instead of doing this whole funny business where you have to square this piece here, what you're really going to do is just take these 2 trinomials and multiply them together. And that will get you eventually x squared minus 2x plus 2. You know, that's just another way to do it. To me, it's just a little bit more work. But again, the only hard part here is knowing to do that, to squaring that piece there. Let me move on to the next page, please. Here's 31, 33. What if it's got the rational roots right here? Yeah. Okay. That's what I thought. So the rational roots for that one, remember the P's and Q's thing? If you did not have your calculator, you would say, okay, I've got the factors of 91 divided by the factors of 1. Remember the factors of the last divided by the factors of our first? So the factors of 91, the nice thing is that's kind of a weird number, where my only factors are 1 and 91, and then 7 and 13. So I've really only got a list of 8 possibilities. So you got a 1 in 8 shot to get it on the first time. So it does turn out to be 7. In this case, when you synthetically divide with 7, you get an x squared minus 6x plus 13, which is quadratic. That's the goal, because at that point you can use the quadratic formula or complete the square. You should have gotten 3 plus or minus 2i. So my zeros are 0, 7, and 3 plus or minus 2i. Please don't forget the 0. That's a very common thing to do. If you pull out a GCF of an x, that you have to include a 0. If you pull out a GCF of just a number, that's when it's not included as a 0. Like if you pull out a GCF of a 10 or something, then it's not a 0. It's not included in the 0. But if you pull out like a 10x, well then yeah, x equals 0 is your solution. Number 33, you did not have to do any sort of p over q because that does factor. It's x squared plus 9, x squared plus 5. You can set both of those equal to 0 and get plus or minus 3i and plus or minus I radical 5. Any questions on 31 and 33? There's 35. Again, I bet this is the rational roots. Yep. So it looks like the factors of 6 divided by the factors of 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So again, 8 possibilities. The nice thing here is there are 3 possibilities of a factor within that list. I see that in my answer. You don't know that at the very beginning. But I see in my answer that there are 3 rational roots. So you could have hit it on the first try 3 out of 8 times. That's a pretty good percentage. Doesn't matter which one you did first. It looks like in this work here, we did -1. We factor out the -1, we get an x squared minus 5x plus 6. And at that point, you can pretty easily factor that into x minus 2x minus 3. So x equals -1, positive 2, and positive 3. Number 36, the volume of the box problem. We have the 3 pieces here, x plus 3, x plus 1, x minus 1. We multiply all of those out, I get x to the third plus 3x squared minus x minus 3. And I want to know when the volume is going to be 105. So I set it equal to 105. I subtract over that 105 to get the polynomial x to the third plus 3x squared minus x minus 108. Now at that point, that's when you would have to factor that down. Think about this. If you did not have your calculators with that problem, that becomes pretty difficult because look at all of those possible rational roots. Factors of 108 divided by factors of 1, plus or minus 1, 2, 3, 4, 6, 9, 12, 18, 27, 36, 54, and 108. So 1, 2, 3, 24 possibilities. And guess what? In the end, there's only one. Right? There's only one rational root. Turns out to be 4. Okay? I would never do something that cruel to you on a quiz test. That's just evil. So x equals 4 is my solution. So I've got x squared plus 7x plus 27. And that turns out to be non-real, which means my only solutions are x equals 4, 7 by 5 by 3 box, plugging it back in. Yes, there will be a volume of the box problem on your quiz. Okay, so here's what yes?
For that one, did we have to do all the rational roots?
The P's and Q's? No.
Because I just plugged it in and saw across it.
Right. Okay, so let me talk about the quiz that's going to be on Friday. Okay, let me talk about the quiz that's going to be on Friday. The quiz on Friday is full calculator. Okay, full calculator. You do not. I do not force your hand. I do not make you do the possible rational roots on this quiz. However, you will have to do it on the Chapter 6 test. Okay. Once we get onward past section 6.6, past this section 6.4 to 6.6 quiz on Friday, then I will make you do the whole P and Q stuff. Okay. There will be a no calculator portion to the Chapter 6 test, which I will make you do the P's and Q's. I'm nice to you on the test. I don't make it like a 108 or something like that. I mean, possibility like a +6. That's not too bad. There's 4 options there. Not really easy. But you know what I mean. But that is not until the Chapter 6 test. This quiz on Friday, you will have the option of looking into your calculator and finding the 0 based on that. Does that make sense? Okay. Here's what I will say. In moving forward as well. There are going to be problems where I tell you to not use your calculator once we get past this quiz on Friday. There are going to be problems where I tell you to not use your calculator. I know you guys, and if you're trying, you get to something that's like 108, and you got a ton of zeros. possibilities of rational roots, it's okay to cry uncle and go to your calculator and say, okay, where is it? And just make sure that factor that you found was actually indeed in your P over Q list. Just to make sure that you were doing it correctly, you would have found it at least at some point. But again, I will not be as cruel to you as problem number 36 with 24 possible roots. All right. Now, this quiz on Friday is sections 6.4 to 6.6. Okay. What does that mean? Well, that goes back to section 6.4 was, factoring. Section 6.5 was factoring to solve, like actually finding the solutions. Section 6.6 was finding the roots, right? So, and taking the roots and making the polynomial out of it. Okay. So that's your quiz. That's going to be on Friday. So here's what I would like to do today. Any other questions on the homework before we move on to the next portion of class? No? I would like to give you a good amount of time to work on your homework in class, like the rest of the period. So like 30 minutes, yeah? Because I want you guys to practice this, and if you're not getting it, I can help you out. Does that sound good? Okay, cool. So everybody at home, so long, get to work on that homework too. Hey Colton. Hey Don.
Got
Back on the screen, Don.